Good evening, everyone. Having problems, I see. Yeah. Indeed. Good. Yeah. Hi. Welcome, Obliterous. Welcome, Aki. Welcome, Steph. 3. Oh, I should ping. I should do a couple of things. Do not disturb. Yes. I need to ping Amy. And disable notifications. Because who really wants me going Bing a lot? Not me. Okay, so the plan today. Welcome, Aston. Good to see you. It's like average of 7 at the moment, but peaks at about 15-ish. Not gonna lie, wish it was more, because some of the fun features don't get unlocked until you have more, as you know. So, today's stream, I plan... Den is comfy, that's true. I plan to, among other things, try and verify all the row 0 key positions, because I now have... ta-ta! Keycaps for the new design. USB gets recognized, that PS2 works, and thank you, Eston, I now have a Glasgow. It's cool. I'm very happy if you couldn't tell. We are also going to try and test the column and matrix decoders because we've never actually tested those, and well, it's a keyboard. That's kind of like its primary thing. We've never tested the primary thing that it's designed for. Yeah, how does he already have that viewership? What? Then we're going to try and verify the silkscreen so that we're happy that that's all correct for a respin. I noticed that the capacitors on the back of all the LED drivers are going to be a problem. That's true. So we need to actually move some caps around on the board, otherwise we'll have design for manufacture problems. And then we need to play with FreeCAD a bit if we've got time. So there's a lot of stuff to do, so without further ado, will get started. I like it. I like it. I am glad it arrived too. It's very nice. So I'm quickly going to grab... Ooh, why is the camera pissed at me? Welcome, Sylvia. Welcome. What was the other thing I need to quickly go and grab? Oh, keycaps, that's right. Okie dokie. You mean you're not gonna stay to see me whip out the Glasgow? Well, that's for later in the stream. Yeah, it's pretty. And I've already had to try and do some pinout figuring, which is why you can see this stuff. Yeah. So, let us get out. I wish. Alright, that would be great. Where are all the row 0 keys? There's an alt key. So we're just gonna quickly build up a row 0 on my desk, and then we're gonna measure a whole pile of stuff. There's a caps lock key. Tux key. Welcome, welcome. Good to see you, Amy. That's a shift key. Oh, there's another tux key. That's tab. I keep accidentally pulling tab out the bag. Ah, there it is. Yeah, I didn't customize this yet. So this is just what MXKeyboard sells straight, but you can actually change this. In fact, you can change all the graphics on all the keys, because you can give them a custom graphic to use to make your keycaps, which is really nice. Oh, I also need the menu key. If we can find it. Tab? No, menu. Hey, there it is. One of the things I will do, because I've had to do custom FN key stuff, is I will share the graphic I designed for that, because it gives you a working known placement for everything for how they do the keycaps, because they don't give you an example file, which is really annoying. So, first thing we're going to do is check how long the caps are. They are... See if I can get this so you can see what on earth I'm doing. At about 22 millimeters. So... I mean, it's a PCB ruler. I won't say who made it because I don't want to support them anymore, but... Which probably actually just told you, like, who made it to half a dozen of you. That's among other many things that particular individual has done, yes. Yeah, we don't support them. Welcome, Naz. Oh, yeah, a little bit of transphobia thrown in there for good measure. So we think that these are 22 and a bit millimeters long, which is basically exactly perfect to what we've just measured. So the big one that I need to check now is the spacebar. So we want 115.6. I don't have any calipers yet. I wish I did, but like I'm having to pick my battles as to what I buy. Yeah, you're a little bit far away. So this is measuring at 118 millimeters, pretty much on the dot, which is a little longer than we've actually allowed for. But I already measured the internals of this. The spacing of these is 50 millimeters. Oh. Now I think these are all the same length. They should all be the same length as each other. So we'll just quickly check a couple of them. That's 22 and a half. Well, 23. Call that. 23. Poor woman's calipers. 23. 23. Oh, this is a PCB ruler. $23 there as well. 23 and 23. Perfect. Oof. I'm sorry to hear that, Steffi. So, I forgot to fix Streamlabs. Whoops. That was a PCB ruler. Yeah, I'm not always good at making sure I update Streamlabs, okay? No boy. Oh, awesome. No, it's not SparkFunds, and I won't actually reveal whose it is because I don't want to support them anymore. So, but you can get decent PCB rulers elsewhere. Yeah, they who should not be named. I like that. I'm just quickly updating Streamlabs because, whoopsie. We are working. Right. Nice. Oh, that's completely the wrong dimension. This is the one we're after. Well, in this case, I'm just measuring the general size of the cap just so that we get the approximate layout right, because as you can see, these numbers have slop to them. So the one that's out badly is actually the spacebar. The one we probably don't want to be out by a lot. This was 118 measured. versus 115.5. Now we actually have... Oh, that's not quite the right measurement. We actually just about have room for that keycap. Just. They're gonna be rubbing. I think. You know, I think I'm not too mad about that. I don't have the board yet. This is trying to finalize this for the respin. The other board's the wrong spacing. Yeah, this is the reworked bottom row. Oh hey, welcome Stephen. It's been a very, very long time. If you're the Stephen I think you are. Nice to see you. So, I think this will actually work out okay. I'll quickly put those keycaps away. And we can actually check something off already on the list. So we've verified those positions. Ah, that makes some sense. I've had a lot of email problems over the years, so... Okay, I think we are now to physical stuff on the board and firmware. Yeah, I think that's close enough that we'll actually just about have enough slop and fit. It is a long spacebar. So, I'm just going to quickly show you this as well, by the way. I've been doing some firmware dev on this. This is SPI Flash Programmer Revision 2, for those who've not seen this before. And I'll do that again in case that was a little too fast for you. That, going green like this, means that it's read the ID of this flash chip right here, and also that it's initialized the full 80 MHz clock, switched over to the 80 MHz internal clock based on this 25 MHz oscillator here. And yeah, so that's coming along. But to the main part of today, we need to do a little bit of work on the keyboard to make it so that we can talk with this PS2 port. And that's where this comes in handy. So I've already done a bit of checking, and I've worked out that with this A port up here, with this way round, we've got grounds here, which is why I've pulled them together and bent them like that. We've then got power and... Ooh, nice, thank you. So I've got the power and voltage sense ones here, and then we've got 2 pins here for our PS2 signals to go on. So we are going to wire a little board so that, sorry, not board, try adapter, so that that will plug into the Glasgow and over onto the PS2 port. So this is going to be entertainment. I need to grab my soldering line. Still nice and wet from yesterday. That's good. Oh, and I'm also going to need diagonal cutters. So, Stephen, I don't know if you're still around or not, but you might want to go and find my Twitter and follow me there. And ping me a message. I'm quite happy for you to private message me on Twitter. I'm sure one of my mods can give you a link if you need it. Yeah. Well, so in this case, because of what we're doing, I'm going to just solder wires onto the board. Because this is never going to have an actual PS2 connector applied to it, so... Thank you, Steffi. Now, we probably... only want, like, that much wire. Yeah, sacrificial dev board. Gotta have a good sacrificial dev board, right? It does already have a PS2 applet, and in fact, Atty, the lovely man he is, went and converted it to proper NMIG gen. So we don't even have to deal with that. Yeah, that'll work nicely. That goes in there, and then that goes onto there. Before I do any soldering, actually, I'm going to prepare a couple more wires like that. It does not, but it supports the host part, which is the bit I'm actually interested in Glasgow being. Yeah, Glasgow's nice. Ah. Thank you. Okie dokie. We indeed have much to catch up on, I am certain, as it's been years. Thank you for actually getting back in touch with me again. It's really cool. Glasgow has so many use cases, it's ridiculous. I mean, it's a USB to anything converter, and you don't even have to feel constrained to use these, which are the various level I/O ports. You can also use this, which is the LVDS port, if you want to put a bit more work in and make it something truly special. That's fair. That's also true, probably, because Obliterus has been doing this quite some time. Well, yeah, you've got the ability, because it's open source, to make more firmware for it. Oh, sorry, more applets. Because it's all FPGA driven at the end of the day. Ah, that's fair then. Yeah, that's a bit more tricky. I really wish I could shake less. That'd be swell. So let's bond these two together. Ah. It's getting a bit warm. There we go. Nice. Ooh, nice. Gotta bend this wire the other way because I messed up on the direction that these were coming out. Now, which part of this is power, which of this is ground? Oh, you can't tell from the board. We'll actually just look it up in the schematic, or in KiCad. So, this pin here is the power pin, and then the one over here between the two data connections. So that's gonna go like that. Ah. That works. I know you've been hurting for work during this period, thanks to various factors. You're awesome. There are a lot of people who I think wish knew half as much as you do about that field. Cool, that's looking like a pretty decent joint. Oh, okay. Talk to you in a little bit then again, Aki. Enjoy the shower. You just asked him questions that needed him to flex his brain a whole lot. I think Oblitrus quite enjoyed your question. Yep, he enjoyed your question. Okay, let's tin this up. While not getting the installation of the other wires, darn it. Oh, that smells horrible. This is the wrong kind of insulation, really, but I don't have any other wire for now. This is... I'm making do and mend, somewhat. Oh, that goes okay. Yeah, this is old. This is an old purchase of mine that I'm still just trying to work my way through. As you can tell, I've got just so much of the damn stuff. And at the time, I wasn't as well versed, let's say. It'd be really nice if this would stay looped like I'm trying to force it to. That'll do. It's not great, but it'll do. It's like the wire itself. Not great, but it'll do. So... yeah, that's fair. Silicone wiring is just, oh, so nice. This is, yeah, PVC kind of garbage stuff. Yeah, I know it's not a simple project. She's picked off quite the large project as her first RF one, but well, the dev kits for that thing are just they're just the board, they don't come with any parts on. So, good luck, have fun. Ow, that's hot. This wire conducts the heat of my iron way too well. A lot of people keep saying this about HF. It's not that it's spooky, it's just that most people haven't been taught it because schools suck at teaching it. Ugh, come on. Like, it's relatively simple right up until, like, multi-gigahertz. But it's just really terribly taught. Yeah, and good luck to you if you've never had a RF job, which, as hobby electronics engineers, neither of us have. Yeah. Ow, that's my fingers. Yeah, I did just go and burn myself. I would appreciate that right about now, you know, Steffi. I would really appreciate that. Ow. There we go. Oh. It's coming back. There's some nice joints. And I haven't really got a preference for which hole these two wires get stuffed in because I can remap it in the applet. I just care that they're stuffed in. Yeah. That's a fair comment, Steffi. Right. I would apologise about what I'm about to do, because you can't see, but I can't get to the joint otherwise. There we go. It doesn't look terrible. Done worse. But more importantly, we now have a usable connection to my Glasgow. The exceptions is going to be the hardest, I think, for Aki to deal with. Just because she likes there to be rules and you follow them. Hmm. Oh, nice. Right. Just going on a quick maneuver down my desk so that we can make room for everything. Existence is noise. I like that rule. Come on. I know you fit because I had you in there earlier. Oof. Yeah, special purpose degrees like that get my goat. Like, is it really that hard to go and teach students how to do a bit more than just one thing so that they've got job opportunities for life? Hmm. Oh, I see. I mean, monocultures aren't great, but fair. Come on. So this is all a rather good sign so far. We haven't fried anything. And it's all working. Take that out of the loop for a second because I actually need to go and grab cable from the back of my... Huh, interesting. I've actually just realised I actually need to switch out this cable because of what I'm about to do. Because I need to... Glasgow is, as you can clearly see there, connected via a Type-C cable, and this is a short micro B cable, so I don't have enough USB ports up on my desk right at the second. FPGAs are good. So, let's get that plugged in here. Sorry if the sound's going a bit haywire. There we go. One Glasgow, and if I now do that. Good, that's all looking quite happy. Even if the USB cable's not exactly the most happy right now. The other cable I need. Digital multimeters, I'm not really the right person to ask. I don't have any good ones because I couldn't afford any at the time. So, but yeah, it really does depend on your price range. Steffi's so right there. Oh, no, that's the wrong way up. Of course it is. There we go. That's a good sign. It's a hell of a mess of hardware, isn't it? Fair. Yeah, you do spend a rather egregious amount of time having to continuity test. Good continuity testers, though, are really worth their weight. Right. We are now going to switch over to VS Code. Nice. So, in theory, this is a UART of sorts. However, we don't want it in SPI mode. The other thing we're going to want to do is... I updated this only earlier today, so we should be up to date and able to run all the kinds of fun things. So if we do that, we should see my glass go, and indeed we do. It thinks it's a C1, it's actually a C2, but like firmware doesn't really exist yet for the C2. Nice. I'm actually just thinking I'm going to add a camera capture in so you can see what I can see. Interesting. Where's the... Brutalist can be good. So we want... Now I don't know if this is the before or after conversion version of the applet, and hopefully Atti's around to be able to help us, but... Oh cool, we can actually send, like, hello world to the board and see if we get that. So we're binding to port A the pin 0. This wire goes to the left-hand one. Which is that. Oh, that's the data line. Pin 1 must go to there then. Nice. Yeah, because that's definitely pin 1. Excellent. And we want to set the output of this port to 5 volts. I mean, what's the worst that can happen, right? It should be okay, though. And... because I've got a no shit button here if I need it. The other thing we are going to want to do is then say that. Oh, that must be in hex. Okay. Nice. Yeah, scalpers can go eat a bag. Take care, Stephen. There we go. That's what I need. That's a good sign. Nothing went pop. So, let us figure out how to configure the UART. That one. It would also help if I actually had the datasheet for the ship up, wouldn't it? Huh. Oh, why did that happen? There it is. Sorry about that. Thank you. Interesting. That is the same as this, but just not on the Wayback Machine. Cool. Ah, this is an IBM one. Yeah, the original IBM source, indeed. The first thing I really need to know is what the data rate is. Well, with how Glasgow implements the specification, that's a good thing, because it does implement it very strictly. Of course there is. Welcome back, Aki. Yeah. Agreed, it is indeed a gnocchi. Cute. $30 to 50 microseconds. I'm looking for the duty cycle, the baud rate. So, 10 kilohertz. Slow. Leisurely pace. Oh, don't tell me I have to effectively have a freewheeling clock. Is that how this shit works? You have to have a freewheeling clock? Oh, yay. That's gonna be a riot, isn't it? And optimization that isn't, because it actually makes it really a pain in the butt. Yeah, I know. Oh. The PS2 mouse and keyboard implement bidirectional synchronous serial protocol. I mean, that's fair enough. The bus is idle when both lines are open collector high. Yes. Even on a modern machine, technically it actually causes the CPU interrupts. It just might take a moment for the data that gets in on the port to then be processed up through the kernel stack, depending on how hellish user space is being at the time. I have to work out then how to configure the UART to generate a clock with the output buffer set as open collector. That makes me wonder... Yeah, pin control XCK. Okie dokie. Take care. So we want synchronous master mode, as it's called here. Which will be called synchronous controller mode inside the firmware. Ah, this is the other reason I'd pick this device. That's right, because this has the right frame formats. Because this protocol is just such a pain. We have to have a start bit, and we have to have a stop bit, and there's a parity bit. Yeah. Which this does support. So let us processor and comms. This is the port E UART. If we can identify it by that way. Arr. Yes, we can. Is it E1 or E0? It's E0. My brain is a completely different microcontroller right now, which is great fun. PE1. Then we've got PS2. Is this data in or data out? For those wondering, I've had my brain stuck inside the clock engine of this thing most of today, so that's kind of where my head's still at. Which is very frustrating. Those of you who follow me on Fediverse know just how badly that went. And just how terrible it was. That's the event routing stuff. I'm searching the datasheet in hopes I can find the right bit of port E's data to know what the pinouts are. I wonder if I was actually originally going to use the SPI port. I don't recall now. Nice. Awesome. Oh, welcome back, Amy. I'm trying to find the right bit of the datasheet at the moment. And struggling. I don't want the peripheral map, I want the pin map. How hard is this? I just want to know what pins are where. Ah, I/O ports, that's probably what I'm after. Wired AND mode. That's right. Because what we can do, this chip has a really sneaky thing it can do. We can be generating the clock and then reading back what the same pin that we're generating on is doing. Because the read and write halves of the pin are completely independent pieces of hardware. And they can be used simultaneously. Oh yeah. No, that didn't find me the bit of the datasheet I'm after. Oh my goodness. Why can't I get just the pin out, damn it? Oh, because I'm looking in the wrong datasheet. I need the other datasheet again. Well, let's just quickly fix this bit at least. There we go. So, port E. Is this actually listed? It's also pretty infographics. Not helpful. This is what I mean about the input-output drivers. So what we can do is we can use this wired AND mode here, where we've got a transistor in what would be the open collector half of things with a little pull-up inside the chip, and then the pin with an input. We can still read the input while we're driving the output. Alternative pin functions. Oh, at long last. RX on pin 2. And transmit on pin 3. Excellent. So, where's the... We'll grab that real quick, because we do need that. But this time it's going to be port E and the bottom pins. So we've got a data register. We don't care about that right now. Status register. We also don't care about that right now. This can do hardware parity checking. That's good. Okay. Let's use E0. Control B. Doesn't have any constants? Oh. Really? You can do it with the parity mode at least. So it looks like that is what we want, because we want to enable the the receiver and the transmitter. I know stuff to do with them. What exactly are you after, Aston? That really depends a lot on the interface that they're using. If they're something like an SPI interface device, they only have an 8-bit mode, but if they're a parallel device, then usually, yeah, you can get both both 8 and 16-bit access modes. So we're wanting an 8-bit character size with odd parity. We're in synchronous mode. Curious. We're not interested in the interrupts right now. Oh, rip Steffi. Sorry, but... I'll show you the datasheet, because this is kind of doing my head in. So we've got C mode here, which I'm setting as synchronous USART. You don't want a bit bang PS2. You want as much hardware support for this as you can. Yeah, that'd suck. We're asking for odd parity. What does SB mode do? That's the character set. We're asking for 8-bit. It's not that, it's the fact that you've got to keep generating the clock, and there's a lot of monitoring involved if you do it by bit bang. You basically can't do anything else on the processor because the host can do anything at any time. This is the stupidity that the device generates the clock, but the host can pull the clock low, signaling halt. True. Aki, I am actually contemplating why I didn't do something like that right about now. Yes. Because this is a giant pain in the ass. There's the odd and phase. Oh, this is for SPI stuff. Okay. So we actually have this set up correctly now. Oh good, there's a table. Oh god, that's a hell of a table. Oh right, I first have to remember what You're okay, Eston. You're okay. I'm trying to remember what our F per is set to on this board. Did I make a note of it? Because it's designed by White Quark. And she is just amazing. Good question, Steffi. I shouldn't laugh, but that's, yeah. There it is. Okay. So we are running on a 16 megahertz clock. That's fair, Aki. You and White Quark really need to have a chat, Aki, because you'd really get on with her well and like her, I think. I'm just saying. Eston, we've got to make this happen. We've got to get the two of them talking. Aki's too shy on her own. Yeah, the table for this is not great. It's... Yes, indeed. Oh, sorry to hear you're having problems, Naz. I have a funny feeling that right there is setting our F per to be the same as the main system clock. Let me check. No, I didn't mean... Doll. I don't know what page we were on. Oh no. There, okay. Awesome. And adorable. I approve, Eston. I approve. Oh god, we've got to deal with the PLL on this thing at some point. Today. Not another PLL! Oh no! Oh... Thanks, Aki. Prescaler A, no division. No, it's the fact I've already had to deal with a PLL today, and that other PLL was so super cursed that just... Why? Well, actually, it's the PLL wasn't cursed, it was the clock hardware that comes before it. Oh, jeez. Okay, you've asked for this. I'm going to show you the cursed. The just so... very cursed. So this is the datasheet for the microcontroller that's on SPI Flash Programmer, and that's the clock tree. No, Steffi, it's not weak. Aki, we're already starting. We're only getting started with this. So, you're like, oh, main oscillator, great, okay, and it goes into MUX, controlled by OSC SLC. Oh, B, D. Oh, there are 2 clock control registers. Oh, fun. Okay, okay. Goes into a PLL. Great. And then that can be divided by 2, or not. Bypassed, or not. Divided, or not. Bypassed again, or not. And also, to top this off, notice this. Yeah, this is a really bad clock tree. So, MOSC dis, main oscillator disable. Let's just quickly go down to the register for controlling this little pile of poop, which is this one right here. A clock tree is the hardware that can steer various different clock sources through the chip to generate the various required clocks to make everything work. I hope that makes some sense. So, there's a MOSC dis right there, and it reads as a 1 by default. Cool, so anyway, the first thing you do with this thing, right, is you just disable the disable. You re-enable main oscillator. How do I know when that's up? No, really, how do I know when that's up? There is no way to check. You just have to bet that after a set number of cycles, which is set at something like 500,000 cycles, that it just happens to be up. And switch to it. And pray you don't just stop right there and then. Yeah, really. It's so cursed. I hate it. So you can literally run yourself into a brick wall with that thing. If your oscillator fails to start up, you're boned. Get rid of that search now. Per 4, per 2, there we go. Clock per is prescaler C, and we're setting this to a division factor of 1. Excellent, we're on a 16 megahertz peripheral clock. I should note this down. What was called? So, with that note made, welcome, Matty. Look what arrived. Oh, I am having the time of my life right now trying to figure out clocking for a peripheral. Oh yeah. We're doing this again. Aww. That's just mean. So, what this horrible table here is trying to say is if the baud rate you want is half of the peripheral clock, so half of 16 megahertz, i.e. less than 8 megahertz, then these are your formulae. Steffi Cutie. She really does live up to her username. So, well, you do. You're an awesome cutie butt. Yeah, I wish. So we've got 10 kilohertz as our desired baud rate. Indeed. And we've got a 16 megahertz system clock, so we need a division of this. Which means a B cell of 799. Do we even have... I don't know if we've even got bits enough to represent that. as you can tell, by the way, I have recently been having to do a lot of documenting of complicated code. So I'm starting to write these kinds of comments where it's like, this is how I arrived at these values, because just, jeez. That's good, I guess. It's certainly less annoying than having to go looking everywhere for what on earth you did to get the value you did. Oop. So... where is... I mean, having pull-ups in output mode is actually something that's really handy if you're driving, say, only one half of the signal by being open collector or open drain. Yeah, that strikes me as a bit silly. Huh. So we can probably use a mix of B-scale and B-cell to get there. And we might want to use clock 2x. Aww. This one, because it can do proper OD driving of the clock signal out, we're able to get away with using that and the resistor inside the package to drive a signal, but allow it to be pulled down outside the package and read that back in, which is cool. So we have 12 bits of yeah, the clock pin is bidirectional. It can be both a peripheral and a controller. I mean, it kind of has to be able to do it because it does support SPI peripheral mode. So, I mean, yeah, it's very nice. Hey, we only need 10 bits. Excellent. So, actually, we can do an exact value by setting B scale to 0 and using just B cell. Okay, so we need to set B up first because of the way in which this all works. How's best to do this? I think I want to do this. Aww. Can I get it to just tell me what that ends up being? Yeah, okay. Perfect. Aw, that's a shame. But yeah, that's fair. Now I think that sets B scale to 0, which... This was saying, I think, that I can leave that as 0 and it'll just work. Yeah, if I leave it as 0, we should be good. Oh, cool. Now, I've done all this work to set this up, but can I get it to freewheel? That's the question I next have. Yeah, we don't want to deal with that. That's fine. Yeah, no, we can't get it to freewheel. That's annoying. What's the various modes we can ask it to go into? Yeah. this is like 10 ways of being really annoying to deal with. A freewheeling clock is one that is just continuously generated, rather than one that is burst mode, for example, which is what a UART, a synchronous UART would normally be, where you only generate a clock when you're actually transmitting, and then you get a clock in when you're receiving. This is not burst. This is very annoyingly not burst. Where was the exact bit? The device always generates the clock signal. Although, I wonder. Yeah, synchronous to the SPI, to the PS2 port clock. I just had a wave of sudden aha. We want to have the bus pull high automatically. When it gets pulled low by the host, we then try receiving by writing to the transmit register, but with the transmitter unhooked from the bus, which will generate the clock signal only. Then we'll get something in the receive data register. I think that makes sense. I think we've got this. Yep. 20 ways of cursed. It's all because I can control the DIR set here. I can make it so that TX is not an output. Which means we'll still get the clock, but we'll get zeros going out on the bus. I will only read. The peripheral's still going to help us a hell of a lot. I just need to find the pin setting where I can set where the, not where, the polarity of drive and all of that stuff. Aha, there we go. Because one of the things we can do is we can say that we want to use one of the int level interrupts, but we mask and unmask it for when we're transmitting and when we're not transmitting. I haven't enabled any of that stuff at the moment, although I probably could. I've literally only got it doing the timers at the moment. I probably should set some of that stuff up, but I haven't done so yet. Do we want wired and or wired and pull? I approve of it, Steffi. I definitely do. What we're gonna do is set up. Now let's see. clock as so this is pin 1 control that we're interested in messing with. We don't care about inverted I/O. And I don't really want to mess with slew rate limiting right now. And we also want to set this to be a low-level sense. That's fair. Given the frequencies you're dealing with, Aki, I think that's a very sensible way of looking at that. Oh yeah, we can also do remapping. Ha! I'm not going to do that though. At those frequencies you don't want to have to do that. Oh, I see. So we've got two interrupts that we can use. We are interested in setting up interrupt 0 mask, and we are going to enable it on pin 1. But then also just mask the interrupt off for now. So this is 2, I think. Yeah, this is fine. Okay. So what we want to then have is PS2 into, or no, IRQ PS2. I think that'll be good. Yeah. I don't mind Aki, for what it's worth. Fair. Oh, not OSC. Bollocks. PS2. Wait. we're actually going to mark this no accept, because we can't throw exceptions, so... why not? Okay, I did it this way. PS2 IRQ. I've just noticed there's a thing we can fix because we're in C++ 17 mode here. We can actually make these attributes square bracketed, but that's for another point in the stream. Bloody hell, I've already been at this 2 hours. PS2's complicated. Who knew? Oh, right, most people. So we want in the interrupt to port e.dir set so what we're doing is we're unhooking the transmit pin here. We can then do port, not port, sorry, usart e0 dot data, yeah, data equals 0. So we write out 0 to the port, which is actually going to read the data in for us. But we're also going to have to take into account aha! So what we're wanting to do now, we're in this state when we get into the interrupt. Oh. Yeah, I guess. I'm just trying to work it out. We want to wait on a spin, I think, on the data line going low. Fair. It's the receive pin that we want to monitor. Yeah. So we want to wait on data going low, which is the start bit here. Oh, it's in, not... Yeah, I'm having a really hard time with this too. Would that be the don't do it option? Agreed, Aki. Agreed. I mean, I don't know how that would help me in this case, Steffi. I've got clock gen sorted. This is trying to figure out the data timings and how to get this to read the data from the device properly. I think, oh, I see. Which bit am I trying to look at now? I've got... Oh, that's right. I was going to look at the other data sheets here to do with the... or the other information we've got here, rather, to do with the protocol. What do we want Glasgow to send so that we can prove that something worked? Because what I'm going to get the LEDs to do is I'm going to get them to show one color if one thing happens and a different color if something else happens. That's going to be the easiest way to figure out if we've got this right. Anybody care to help me with how on earth I instruct the keyboard that, hey, I want you to initialize now? Because I want to send the right start command. I don't want to just say hello world or something like that. I actually want to do something more sane. That's okay, Aki. You're allowed to not know. Of course this doesn't fucking tell me. Really? Do you see this? Really? Ah! I can make it work with this controller. It will actually make it easier because I don't... What I'm trying to avoid doing, Steffi, is I'm trying to avoid using the very limited number of timers I have available inside the chip. Especially because they're actually way harder to program. This is a balance between let's use the peripheral that we can make mostly work and timers. Timers are the only other way I've got to do this because I've got to drive so much other hardware here, right? Yeah, timers. They suck. What I can do is because it's essentially 9-bit, I think that is. I mean, let's count the clock pulses. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. The axe on the 11th one here, I can just generate that manually. Because the main protocol here is start 8 bits, parity, stop, no more clocks. So it's 10 clock pulses, but this is 11 clock pulses, and I can just manually generate an extra clock with the data line set to the right bit. So that actually is not really hard to do, and we can let that be a little late if we have to. There's a bus reset phase? Okay. This is interface. This looks like this is your converted module, so we're good. I just need to know what line I'm looking for. Did you actually change the signature on the top of the file? No, you didn't. Oh no, it is the MXGen compat version still. I think if we do that, yeah, I haven't yet. I don't think it's yet been merged in, so I don't yet have it, but that's okay. Fair enough. What we can do, I think, is if we do this, that arms Glasgow, which we can now see is done, and if we then build the firmware, why does that have different exception specification? It shouldn't, but okay. And if we do Ninja Program, I think it was? Yeah. Nope. It's dropping out of communications. Interesting. Doop. See? Oh, whoopsie. We see this is coming up. That's fine. Yeah, I didn't actually mean to reset my Glasgow. Interesting. Oh, now it wants to just work. Whatever. Halt and catch fire. I guess. Sorry, trying to move the camera ever so slightly so it's not quite so close to the edge of the desk. That hasn't actually brought data back in. Curious. What we are going to quickly do then is attach a scope. Well, we're finding out together. It's all good. I need to quickly change the power cable in the back. One sec. Yeah, I should be able to send and receive bytes, so what I've just done is I've just set my scope up so that we can then probe, maybe. Coaxes for these are a bit fiddly. What? Oh, right, because you're looking right down in the noise. Your data sheets. Yes, agreed. That would be awesome. So, that is reading as high. I'm sorry you can't see the scope today, but I'll tell you what's happening as and when we get interesting results. I guess. just fits, barely. Ah, come on, let me get a ground there somewhere. Okay, we are hooked up. It is idle. I didn't do a damn thing. Which pin is which again? This is going into the right-hand pin, which we said was clock, I think. Oh, okay. Yeah, scope how should be something we have another look at. Take care, Naz. Yeah, I thought you could also talk to it though when you're live. Ah, okay. What we'll have to do for right now, we'll have to fix that bit of the schematic up later. There we go, now we know what we're looking at. So the clock pin here is my channel 1. So if we quickly reconfigure channel 1 as my negative going clock source. That's the wrong window, that's the one I want. Yeah, okay, that didn't do anything. That did. I'm on the wrong time base. I'm still on the wrong time base. Jeez. It's slow. That still isn't happy. Curious. Well, it's not because of Glasgow. Glasgow's doing exactly what it should do. Yes, you should, dear. That would be a good idea. Yeah, that doesn't even trigger an interrupt. Jeez. Okay, so I'm gonna say... I'm going to do some offline work on PS2. Because I don't want to drag everyone through this even more. We're gonna just go straight to trying to get USB up and working, because it should be easier. I think we've got problems with this logic level translator, because I'm not even seeing our attempted A getting sent out the board. Nice. Atty is good like that. Cause CMake. You answered your own question just by saying the word CMake. But I think you already knew that. I still have ideas and uses for my Glasgow for today, so I'll leave it up there for right now. I'll just move a cable out of the way. So... in this case... get rid of that as well. I will for now... comment out the PS2 in it. It does not support VNC. It is on the network, well it's capable of being on the network, but it only implements the LXI protocol stuff. It does not do VNC. Basically, I can send Skippy commands to it, and that's pretty much what you can do with it. I mean, it might VNC, but I doubt it. I very sincerely doubt it, and I also don't have VNC installed right now. To do USB init before or after DMA and LED init? Before. No, after. After. Oh, this is why it was angry at me. I'm just going to re-architect something real quick, because the hat needs to go in here and be quite internal. So also that should go in there. No, not there, sorry. In there. Undefined USB in it. Yes, that's fine. That's what we want. We're going to need a USB types header. So did I close that header already? I did. Whoopsie. We want to start by enabling the PLL required. Because we want to set up a full speed USB peripheral. So, okay, I'm going to do a thing right now where we're going to set up some nomenclature. Instead of calling it USB out and USB in, we're going to call it controller out, controller in, so that we never get the directionality confused. Because this is something that USB itself just gets wrong. And I've spent many an hour with my head hurting and it not working. Oh, this is gonna be fun. So it looks like we've got an internal structure we're going to have to keep. Oh, yay. But how do you set up the PLL? Oh, okay. We'll start by setting up the USB controller. That works. Somewhere in this list is USB. There it is. That's not very much help that the header gives us. Yep, this isn't going to be fun. Oh well. So controller A, we want to enable the peripheral. Ah, now this is actually quite good that I've already created a types thing here, because what we can do is namespace vals, namespace USB, const expra, static const uint8t, control A, USB enable, and this has a value of hex 80. This is the high bit. We can then do mode full speed and mode low speed. I actually got those upside down. And this is really, really cheap, because the compiler will actually do all of this computation for us, and we'll just get the value that we need. It's great. Yeah, yay const expra. Let's see, we want to attach to the lines at some point. I might as well actually just go through and define all of these bits. You broke your compiler? How did you manage to do that? Okay. Good go. Oh. Oh, good. This is awesome. There is a value that we can encode that is the maximum number of endpoints that we support. Yes, because we can now say we only want to support endpoint 0 in and out, 1 in and out, and 2 in and out, because we only want to support control transfers, DFU, and keyboard usage. That's 3 things. That's it. So we do this by doing const expra static inline uint8t, control A max EP. Well, let's do into 8T. Only that dash J32? Weak. I'm sorry, I'm spoiled for getting to do dash J256 too often. I know. Hence I jest and only jest. That shouldn't be diagnosing as unused. Oh, there we go. It doesn't want to be static, it just wants to be inline. And then we can then say max endpoint is 1, 2, 6. Oh, except I do need to make sure I address the namespace. Okay, take care, Atty. We'll probably still be at this in like another hour, because USB takes a while to configure. I don't know that I want to enable pull RST or remote wake up. Oh, cool. We can enable and disable global knacking. Let's define some constants. So clock during reset is that. Remote wake up is that. 2, we've got 1. Global neck. And attach, which we actually do want to do. So we want to do that. I don't even know if that's already sufficient to make the device do something, but I actually do want to write some more of the control structures first, just in case. So we'll need to program the address register once we know what the address is. Ah, here we go. The endpoint configuration register needs setting up. Oof. That doesn't sound good. So this is where the endpoint configurations are stored. How did I do this on a previous thing I had to do USB on? Let's go looking in my file system real quick. That was a CAN bootloader. Where's my PIC 18 USB? There it is. Oh. Yikes. Yeah, that's not good. At least not like that. Hi, Kiwi Anxiety. Yes, you did. I've programmed on PIC, I've programmed on AVR, and I've programmed on ARM, and obviously x86. In this case, I wrote a PIC18F USB stack. Yes, you can find it on GitHub. No, the code's not all good, but it works. Welcome back, Aki. Ah, this is using the... which USB device was this? This was the PIC18F... I don't recall what the rest of the numbers were, actually. I know what it came from, though, so I can quickly look it up. Let me go back into... Ouch. There we go. That's what I was looking for. It is in here. What pick did I pick? Or was picked for me, really. It doesn't say there. It might say in the NetBeans project, though. I know NetBeans. Ew. There we go. It was the PIC18F25K50. It's actually a really nice chip. It works very, very well. And I've got a complete and working USB stack for it that we are going to be pulling some small bits out of to make this work, because there is no vendor stack for this that I care to want to try and use, because they're mostly a pile of crap. So we're just trying to work out how to configure this endpoint configuration table pointer correctly. Hey Derek Boom, welcome. Okay. That's the FIFO. We also need to do this, yes. Which we need to configure the PLL for. And this table's the other way up, just for extra fun. Ugh. Yes, I've done that, and I've already got a PID code. Actually, I've got two. I've got one for this project and one for the SPI Flash Prog. Entertainingly enough, it took them less than a week for them to say yes, for me. Go figure. I'm lucky, I guess. In fact, the PID code for this project is BADA. I'm just trying to work out at the moment, like, status control, then, oh, okay, so yes, this is this structure. Excellent. I will give you the hint, Steffi, that the organization that these two projects are now under, for the purposes of the PID codes, is called Badalok. It's not so much a joke, it's just an Easter egg. I had some fun allocating the PID codes. Well, yeah, true. Badalok heavy industries, but Badalok is the main part. I think this will do the trick if we say... Actually, we'll... Endpoint count is going to be in the types header and is going to be a static thing, so don't worry. This will all make sense in a second. And this needs to be 6, because we've got... Fair enough, Steffi. I'm glad it did build though. Actually, I'm gonna use stored array of USB EPT endpoint count because it's safer. And we'll need to pull in the array header. Uinputter T is defined on this platform. I don't know, reinterpret cast. Yep, that's all good. That builds without errors. Very nice. So the next thing we're going to need to do, and this is actually the reason I've got the USB driver here open, is we need to set up the oh, it was USB requests that I did this in here. We need to set up descriptors. Oh yay. I think, did I? Yes, I did add handling for EP0 in here. Huh. Lewd. Thanks, Aki, for lewding that. That sounds like you've got a bug there, Aki, that you need to give to the maintainer of the package. Oof. So it just goes nuclear on you when it doesn't like it. There it is. Losing headers for a second. Mew mew. Nice. So, God, so many C-isms here that I'm gonna have to clean up as we go. Aw. Fair enough, though. Welcome back, Atty. As you can see, I am slowly going crazy. I'm setting up USB descriptors. That's what's going on. Actually, we're in C++ 17 mode. What am I doing? Duh! I could just do that. Oof. So rather than typing a whole ton of stuff out again, I'm gonna copy paste a whole pile of stuff instead. Oh, this is hilarious. This is so C of this. We can do enum class that is uint8t, and then descriptor type can actually just be that. There we go. Fixed it. Well, not quite, but I can now make it nice and proper the smart way. So we want descriptors. That, there we go. Fixes that error. Get rid of that because we now aren't using that. We've got it elsewhere. Now, technically we are in device hid, sorry, class hid, rather than communications. So I need the USB datasheet. This is me going slightly crazy because I've had to look at the USB datasheet a little bit too much. I've got Clang Tidy partially configured on this project, but I tend to not allow it because it fucks up my particular style of layout. I don't tend to allow it to just make changes. I let it advise me what I need to change, and then I decide on what I want to change, and how. But thank you for reminding me I do need to copy in a Clang Tidy file for this project. Is it in the OBR stuff, maybe? I have a complete copy of the USB spec somewhere. Oh, yeah, right there. Among other things, I have a complete copy of the DFU spec. Haha. Which we'll come back to later. And... the... haha... USB 2.0 specification. God help my poor soul. I want to know how the friggin' descriptors work, darn it. I think it's 253 directly in there, should get us close. Yeah, this is the right section. This is the layout of the actual request itself. This is how you get it from the host. These are all the things that the host can ask for. Quite a few of these actually aren't implemented, normally, which is fun. But yeah, this is the thing. Hey, there we go. Found them. It's a handy value to know, but it's not what we want here. The bigger one that will help me right now is actually going to be to go and find the HID spec, because that gives me the exact number I need to put in. I'm just trying to think, do I have it down already, or am I gonna have to find it again? It's not hard to find, but it's annoying. I will also pull that open though and have a look, because that might tell me how the AVR peripheral is supposed to be poked into submission. Or at least their interpretation of it, which may or may not be quite how we want to do it. I have a funny feeling I have the HID spec elsewhere on my pool. I need to pull all my documents together into one place where I've just got a bank of PDFs for all the specs I've got. Secure HMI maybe has this? No, that's not it. Yeah, I've still got a very scattered one because I've been doing this so long and never really had the option to just pull them all. Both. Or okay, for the interests of trying to make this keep going at a reasonable speed, I'm just gonna go and find the blooming thing. And at the same time, we can then go and look up the datasheet that's being suggested. Okay. Or app note, I should have said. Because, yeah, that's an app note. Huh. Cha-cha! There we go. Of course this one doesn't have any of this stuff just working. Why would it? Oh, bollocks. I actually have to go through the pages manually to go and find the actual HID device type value. Welcome to the USB specifications, everyone. It's a great way to go cuckoo and then fall asleep. So this defines the subclasses. We actually want subclass 1. I have a funny feeling this is class 3. See what they've got here. Interesting. This looks to be talking about a vendor stack, which is exactly what I don't want to deal with because they suck at doing this kind of stuff actually right. Turns out USB is actually really quite hard to implement correctly. But I might still go and fish in the source code just to see exactly how they bring things up. Because that might tell me how to PLL. Which means less guessing. Trust me, you don't want to guess this stuff. It sucks to try and guess. Okay. Do they have a list of classes? Device class definitions. There they are. Seriously? Let's see, and look at what my SteelSeries mouse says it is. Oh, interesting. Device class 0. Interface class HID 3. That's probably because I ran it without being root. No. Subclass codes. HID class. Okay. The interface class is 3 for HID. Well, we can do the vidpid part next, I guess. Let's just get that done. So the vid, because it's a PID codes vid-PID pair, is hex 1209, like that. And my PID for this is sorry, not that one. Bada. Those need to be 16-bit. Oof. Sorry to hear that, Steffi. Hmm. Interesting. That actually sounds like the person who did the tweaks should have just subclassed the scope that they were tweaking, rather than breaking everyone else. That sounds like someone just did a really bad edit. Oh, interesting. Hmm. Should be done by Scope Family, right? Oh, right. Yeah, but how do you reconcile that, really? Yeah, this is true. It may be something that improves because the project is under active development. Yep. Okay, that's fine. Using the field total length initializer. No, you're not. Number interfaces you are missing, yes. No, that's the wrong spec. This bit. How big a packet size do we want endpoint 0 to support? That's a good question. Doo-doo-doo. Yeah, uwu works. No, I didn't say uwu, but uwu. It's okay, I am dealing with one of the most boring parts of this entire thing, so you're welcome to space out if you want. Wow. That's kind of a crappy move by it. I actually have a funny feeling I need to support two configurations in this case. That you do. What's our power requirements? Our power requirements, no, they get divided by 2, is 1.5 amps. I know that's what the normal would be, but we are actually running above that, and it's actually within spec because USB 2 got revised. Technically we're using USB 2.1, kind of. No, that's not 500 amps. It's a power number in milliamps. Oh! I read that as milliamps. It's okay. I failed at reading, apparently. Interestingly, max power can't be quoted to be above half an amp. It's not got enough field size for it. Ah. Right? I think there's an extended descriptor somewhere that I have to end up using, or some shit like that. USB is just an exercise in pain and suffering. I'm gonna need those two anyway, so let's just grab those. throw them in here. Welcome to writing your own USB stack, really. Yeah? What happened, love? Oof. Rip. Indeed. We'll need those numbers, not in that format, but we'll need those numbers. Enum class USB endpoint type T. Isochronous bulk and interrupt 3. It would be really handy if I could find the configuration attribute stuff. Oh, there it is. That's fair, Derek. Unfortunately for a USB keyboard, you can't do that though, because that then doesn't work with UEFI and BIOS support for keyboards. It's kind of dumb. Ouch. That's a really shitty thing for the spec to have said is allowed. I have no idea what those small letter names mean, so let's go looking at the spec again, I guess. Remote wake up for that. This is great. D7, i.e. bit 7 of this field, is reserved and must be set to 1 for historical reasons. Indeed. And yeah, this is great. Expressed in 2 milliamp units, but they say it's in milliamps. No. No, it's not. It's in 2 milliamp units. Arrgh. Pretty much. In this case, I think it's a old USB 1.0 problem that bit was used for something and then they went, oh shit, that was bad. Now they're left with devices that have it set, and so you have to say, everyone has to have it set now. Mad. Or devices that didn't have it set that wouldn't work right, and so it's actually used as like a compatibility flag. So if you yeah, I can imagine that's kind of the logic behind that. I really wonder what I should be putting there. Oh yeah, this is the other really annoying thing. You know that Microsoft had their hands in this. It's not Unicode. It's not UTF-8 rather. It's UTF-16. FML. I'm glad I'm using C++ because it means I can say that, well, the descriptors take char16t's and we do U16 double quotes string and it just does the right thing. Yeah. Well, it's the same difference as long as you stay within... No, you do not want to use W string. WCHAR-T is allowed to be defined to either be 16 or 32-bit, depending on the platform and depending on who's implementing the compiler for the platform, and just cry. Now, this is a job for a stud array of char16t. Or rather, a char16t star, because I'm going to use 16-bit character pointer constants. Because it's easy. I get the compiler to do all the encoding for me. Yeah, but I can make it less awful in this case. Yeah, Aki was joking, by the way, about that USC2 is the same thing as UTIF-16. They're not the same thing. The basic code plane is the same thing. However, UTIF-16 is allowed to be multi-byte. It's a superset, but it's also a really badly implemented superset. In UTIF-16 strings in C++ is best handled in this case as just const char16t star const thing equals u16 double quote string that you want to be UTIF-16 double quote semicolon. Actually, conforming UTIF-16 does not have the bomb because it is invalid. However, what the fuck 16 does. Thank Microsoft for going and putting the built byte order mark from UTIF-16 into... yeah. Epsidic is a artifact of its time and actually makes a lot of sense. It does, because punch cards. When you look at the layout of a punch card and what existed before it, it does actually make sense. Yeah. Nice. Oh yeah, it has to still be in use. Oh, yeah, Saki, do tell them this is so cursed, I love it. But yeah, it's still in use in Zeos because it has to emulate punch cards. Oh jeez, I think we just accidentally caused Amy some PTSD. I'm sorry. I'm sorry, Amy. Yeah, it's bad, but yet it's so good, right? This is true. Why am I not surprised that they still have emulation for that? JCL has nothing on batch scheduler stuff in many respects. Oh, interesting. Lol. So it's kind of like a Game Boy has a... sorry, Game Boy Advance has a mini Game Boy in it, as well as its advanced processor. Oh, jeez. Hang on, I think I've just already gone wrong. I need to make sure I'm defining this sanely. Boot interface. Yeah, that's the subclass code. Sleep well, Steffi. To be fair, so is the non-stop. Non-stops are pretty... Whoa. Sorry, Aki, I know, PTSD. Pets, pets. But that thing is pretty crazy and just... Whoa. S390X is the IBM mainframe CPU. It's Z/Arch. We just have a lot of knowledge of them because, well, for one, I'm interested in old systems, and for two, Aki has a thing for old equipment in the form of mainframes, so yep. It's our way to pass some time. Why do I get the funny feeling that Atty is now going, oh god, please don't remind me. Oh yeah, that whole 2 operating systems and just a nightmare. Yes. Yeah. The word battle is being polite. And it's not a polite word. I don't need these, but I'm gonna add them anyway, just because I'll feel better about it if I do. Ooh. Yeah, OSS is so super cursed. Just fuck. Now, there's a good question for stream. Should I define vendor as hex FFU, or should I define it as just 255 and get on with it? They're functionally the same, but like, if I'm defining the rest as numbers that aren't hex encoded... Okay. Should I define the rest of them as hex encoded then? Okay. Steffi, I'm currently writing up the USB device classes, interface classes, while I'm trying to figure out the description of a keyboard to give to my PC. So I've defined a configuration descriptor, which you can see is complete. I've defined an interface descriptor, which we've got to define these two enums for it still. And then we've also got the main device descriptor, which I'm not quite sure what I need to plug into these slots here. And for some reason, USB protocol is not defined. Whoopsie. Ah, it is. You're fine, dear. So in this namespace for subclasses, we want enum class hidT, and hidT entries need to be no subclass, none, and boot interface. We've then got the protocols. This also needs to be a... I'm going to suggest it's that. Yeah. Yeah. Damn it, dear. You've got me to a point where I just seen you nya and I have to nya back. I'm not unhappy about this, it's just... Okay. Yeah. Yeah. Oh, you love it really, dear. That's a mood. So I got none keyboard and mouse. Ha. Oh, whoopsie. Well, that's going away anyway because I gotta do it a different way. Mood. Oh, talking of, I'm gonna take a moment's break from trying to write HID descriptors because, jeez. I'm gonna show you something really, really cool. 1 second. So, I heard you like power electronics. Maybe something involving multi-layer, very heavy boards. This is the power control unit for a racing car. But I'm actually going to rearrange things a little bit so you can get a much better view. I wish you could, but yes, something like that. Oh, no, don't take that with you. Ah, don't get caught, you stupid thing. I'm sorry for the really, really horrible camera work there. Oh, this is way more interesting than those. This fun thing, this is a remnant from an old job. This would make a Tesla blush. Oh, I see. There we go. So, ignoring some of the warnings about problems, this here is where the car battery attaches. This is a board that has, if I recall correctly, yeah, it's chunk. 16 inner layers. The bulk of the inner layers in this board, something like about half, are 3-ounce copper. Either 12-volt lead acid or 24-volt lead acid. These are intelligent MOSFETs. Previous job. And I don't know how much it cost, and I don't want to know how much it cost. This device is capable of handling 2 channels of 200 amps solid state switched. That's the cold cranking current required for a racing car. Actually, I think it was 300. This also weighs a hell of a lot. No, there are actually multiple power domains here because there are multiple outputs. This is designed to be able to control power going to this one over here. I'll get to that. This is designed to control power to all parts of the car, so it's a whole lot of very chunky power electronics for that. If I recall correctly, it's these 2 here. So there's a bank of them over here. This is the ones for cold cranking, and the rest of these are just general purpose high current outputs, like 50 amps. This thing has multiple processors on it. There are 2 tiny picks over here. In fact, those are pick 16F 1829s. I'll tell you in a moment. This has Ethernet. It also has straight serial. Then there are 2 processors here as well. And down here there's also another pick. The pick here is being used as a watchdog for these 2. You've got a comms processor, and you've got a control processor. The control processor on this is the NXP LPC 2929. I didn't pick it, I hate it. The other processor here, which you can just about read that actually, is a LPC 32... sorry, no. Yeah, 3240. Just in time for some chunky power electronics, yeah. No worries. You've got a super cap here. This is to provide power to these processors during cold cranking. And that is a 0.6 farad cap. You missed this, Obliterous. This board is 16 layers. Yeah, this board is 16 layers, if I've recorded my specs right, and most of the inner layers of this board are 3-ounce copper. Soldering this thing is a pain in the ass. Yeah, this is a hefty board. This is weighty. It's, yeah. It's got chunk. And these 2 here are pairs of intelligent FETs. Yes, I did see that. That's not SMD. It's a press fit bolt. How many pins do you want your bolt to have? Yes. And it ain't going anywhere anytime soon. It is really in there. It would also burn up in the process of handling cold cranking current, because that's the power input for the whole board. So you've got these 2 channels are capable of 300 amps, I think it was, but it's 200 amps continuous cold cranking current. And then the rest of these are all general purpose 50 amp outputs. The MOSFETs, for those who are asking, are MC3398 for CHFKs by 2 starters. Yep, and those are by Freescale. And the other ones down here are MC33981 BF. I'm gonna skip this song, sorry. I'll reread that in a second. There we go. MC33981 BHFK for these second ones down here. That's these 4 here, which also have their own dedicated. It's not a. It's a power control module. It's not an ECU. This sits between the battery and everything else in the car. Everything runs through this. Okay, so if I remember rightly then, these 2 are banked together, and these 2 are banked together to give you 150 amp. Yep. So, also fun fact, each one of the picks that are down here control 1 pair of these. So you've got a core cranking unit, another core cranking unit, a whole pile of I/O handling here. You've then got various bus expanders to talk out to all of this, and then you've got as I say, this is a control CPU for controlling all of these, and then this one here is the comm CPU that can talk to this one and deals with like Ethernet, UART, etc. And actually there's a UART on the output here, which is why there are 2 black lines. Yeah, this thing means gnarly business. But it gets better. This isn't actually a completed unit. You can see all of the manufacturing errors here. And obviously the connectors here are missing. I have a second of these. 1 second. So, what we have here are the car connectors. Chunky bad boys that those are. And those are soldered. Kind of. Fair enough. There's then attached over here, car CAN bus. That's the connector that's generally used. Then it's a very unwieldy wiring harness. Connected, well, was connected over here. This is a UART, which goes off into this cable. And then there's power and ground here and here. Additionally, we then have here a loopback connection for a UART. Oh no, it's current carrying, but like there's a case that goes around this. So these are reference grounds, but they do also kind of do current carrying. But the entire case is current carrying as well. It's a solid aluminium, billet aluminium machined case. I don't have the case. I wish I did. For local logic. But there's actually quite a bit of current that's needed to drive one of these. There's a lot of stuff on here. And as you can imagine, this has got quite a bit of weight to it. There's also, as you can see, like, lots of outputs pulled out here, and there's a ground. There's one of the outputs. Yeah. There's an input. Oh, you're welcome. I've been waiting to show and tell this one for a while. It's, fun. Super spooky board, yes. There's another version of this which is even bigger, which is terrifying. This is the light version. Yeah. Oh. Obliterous will like this one. Let me go and grab something from another box. I'll do another quick bit of show and tell because we're using the USB driver from it to help with us tonight. So, this is rather an entertaining and interesting board. It's not what you think it is. I'll see if you can guess first, and then I'll talk about it properly. And I'll actually make it so you can see that text there. I think you can just about tell what that says. Can we get it to... You wish. They are 7-segment LEDs. This is a ride height control display. So it monitors... This is a dummy ride height monitor, essentially. This would actually be embedded in the wheel hub. Well, a version of this would be embedded in the wheel hub of NASCAR. And this thing reads that potentiometer, which is actually in the wheel hub and is a linear carbon track, to determine how high or low the ride is currently set. And this is configured using USB. Haha. That's the time with today. This is actually the PIC, which the bootloader, not the bootloader, sorry, the USB stack from where we've been pilfering stuff from. And this tells you, when you press the ride height control buttons in the car, where you're set to. So there's a whole lot of analog to digital circuitry in here, and I'll actually read you some part numbers. So this one here is the PIC 18F25 4K 50. Yeah, set point versus actual height. This reads the real height from the vehicle. You've got a AD 8277. That there is a DG409DY. And then finally an Infineon. Yeah, this is active feedback. This is an Infineon ITS 71L1. So this is quite a fun little project, actually. All works. I did get this finished, so, you know, there is that. If I recall correctly, that's a reset button. And this controls the brightness of the display. And it's just got, these two here are just power inputs. I have a lot of very fun toys from this job. It was a very good job right until it stopped paying. Pulse-width modulation and illumination, yes. In fact, quite a bit of this circuitry over here is actually the LED driver. Because it's a scanning matrix. And you can actually tell that whenever you're using the USB port, because being this is a PIC and it's being run at 16 megahertz. Oops. You can actually see the scan slow when you're sending stuff through the USB port. I had no choice on that one. It's just a limitation. CPU's just not fast enough. Needs more CPUs. Needs a faster CPU. Or rather a faster clock on the same CPU. Anyway, I'll go put that away right now. Oh, away. I'll put it on the table for now. Oh, it could already be done with a single ATmega at the time, but PIC was what the guy who designed that board liked to use, so PIC was what I got to use. Yeah, that wouldn't fly, because power is everything in those cars. That would be drawing way too much current. That's part of the reason why it's a PIC. 8-bit micros draw less power. I don't make the rules, don't at me. You want all of the power budget in the car going to other more important things. 300 milliamps sounds about right. Yeah. You want all of that engine power going to the wheels, not to the electrical system of the car. So everything in the car is built down to a very strict power budget. If you can get away with a slower processor, you do. Oh, they make a very big difference. It's the switching frequency. And also the complexity of the core logic. They can. that hardware was designed 7 years ago? And it has a power budget of, I think it was about 10 milliamps, including the displays. Exactly, Atty. Especially, as I say, it's got a display. If I recall correctly, yeah, it's not much current at all. And that's with the USB stack spinning. Yep. PICs are really power efficient. You'd be surprised. High efficiency displays are wonderful. No, the PIC itself is like 1 or 2 milliamps. And that's when it's not in sleep mode, at which point, sleep mode, the power usage on that thing drops into the nanoamp range. So... it can be. At the time it wasn't. As I say, this was like 7 years ago. Things have changed since then. But I can actually tell you exactly how many years ago it was because 2016, there you go. 15, 16, so 5 years ago. The actual hardware was designed a year before I wrote the firmware. Actually, I've just quoted the wrong number because that's for the extraction, not for the original. I don't have it open at the moment. We want to go to... Ride height. We'll do that one. 2015. Yeah. I feel sorry for your friend, Obliterous. Yikes. Yeah. That's not much. You can't even get to the end because your budget's that low. Yeah, that's a fair comment. Yeah, go sleep, Steffi. Go sleep. Fair enough, Ratty, take care. I'm gonna wrap up in like a half an hour. I'm gonna try and see if we can knock the descriptors out the park at least. Oh, you're very welcome. I'm glad you enjoyed. I didn't do that last week. Fair enough. Sleep well. What's for supper, by the way? Ooh, nice. So, done up leftovers. Fair enough. So you did an entire another one today. I see. Well, yeah, I know. It's the same thing as my parents do when they do roasts. And you just have to plan around it. You're like, this is the day we're doing it, and therefore, stuff. Yeah, still a reasonably decent amount of meat. Oh god, I did already fix that. This is gonna be fun. Nice. So it was just falling apart when it came out then. Nice. I'm just trying to work out at the moment, how do I fix this mess? First I need the endpoint directions, really. And then what I'm going to actually do here is we're going to define a small function that converts an endpoint direction and a endpoint number into an endpoint address. So this is going to be const expr uint8t. Probably just go for endpoint address, why not? Uh, 7F, I think, because... yeah, that's right. Nice. There we go. So what we then do here is we do USB, oh not USB, endpoint address, USB endpoint dirt, oh right. This is where we got to put the smart cap on and go, instead of saying in and out, we're actually going to say controller in, controller out. What does the HID spec say about what kind of endpoint I have to define? Has to be interrupt in. It's awesome writing firmware in C++17, I don't know what you mean. No, I get it. Well, I will say this, Amy. Don't these endpoint descriptors just read so much better than the jank I've replaced? We've made Obliterus hungry. As long as it's not hangry, it's okay. I really need to resolve this. Crimey River. How do I resolve that? I think I'm gonna follow after my own mouse here and just set them to 0. Be like, screw it. Aww. It's a MacBook though, so I'm not really too surprised. God, you are vicious. You are really very vicious, aren't you? Oh well. But you're also not wrong. Yeah. I have a nagging feeling we're about to do something a bit spec violating because I should technically be defining this against composite device, but I'm not about to go and get the composite device spec out because ugh. Ah, I pluralized them. There we go. Okay. Whoopsie. That should just leave 2 errors in these descriptors now. Let's just verify that with a compile. Compiler says yeah, just the 2. Good. That was my neck. So what I've just changed here, this is a total size field that includes the size of this descriptor, this set of descriptors, and this set of descriptors. Yeah, it's a fun time. I should probably actually describe this as size of that multiplied by that. No, sorry. It is always that, but size of this multiplied by that, and so on. But am going to skip this one. Because I now need the multi-part descriptor thing I decided to build. Ah, of course it's not in this header. Why would it be in this header? It must be in the requests header then. Nope. We are going to need that, so... Ah. There we go. That's how to work smarter, not harder. I used an IDE function just to go straight to the structure. I'll figure out the proper definition for this in a moment, but this will do for right now. So we want... Now I know what I've just done is technically wrong, because as you can see from this side here, after the interface descriptor we're supposed to then have the reports defined, but we haven't yet got a structure for that, because I haven't got there quite yet. Yeah, so it's this arrow here to the HID descriptor. Would it mind actually telling me how those are defined? Okay, there's the HID descriptor. That's good. I hate this way of describing this. So what's happening here is this first number is how far into the structure the thing is, and the right-hand number is how big it is in bytes. Would it like to please name what that constant is? Apparently not. Apparently it's defined in section 7.1.2. Okay. What do I want to name that? Other fields like that I have. I called that one USB version, device version. Do I have any other BCD stuff in here? Oh. This is frustrating. I think I'm going to call it HID version. And we've got a country code. Oh my goodness, I can't type. Number of descriptors. And then there's this thing that follows, which is this alternation of a type and a length. Actually, I just realized what I can do is we can do a namespace at this point. And we can then call this a actually, what would that be called? Because it's essentially a count of the continuation descriptors. I guess report descriptor? Hit report desk. When I don't accidentally add that to the wrong thing. So we've got a report descriptor. Frustrating, frustrating. Yeah, actually this will make sense, because if we have a descriptor, a report descriptor which defines the size of that particular report, there's then a variable size, variable type descriptor that follows that, which we then have to fill in. Okay, this makes sense. Not a great sense, but it does make sense. Yeah. Yeah. Yeah, I know the time has ticked. I really want to break the back of this. Oh, right, this is a BCD value. Seriously? They don't define the value you have to give. I think that's correct, because it's 1.11. Which, if we look at the version of the spec here, 1.11. I think that's right. So we've got not supported, as 0, Arabic is 1, Belgian 2. I'm going to move this window to the other screen so I don't keep having to tab back and forth. Yes, I'm putting a joke in there. Nope, you can't stop me. Indeed. Well, you can either now be Canada Bi or Canada French. You're welcome. Apparently, the spec got hungry. Oh, that's so good. I like it. I love it. Actually Japanese, because they don't define any other kind of Japanese, so... I'm actually going to say this is just Czech, because we just call the language Czech. This is really inconsistent. They keep switching back and forth between naming countries and naming languages. Ah! It's like apparently it's not Russian anymore, it's just Russia, and it's not Slovak anymore, it's Slovakia. But then it's Spanish, didn't you know? Yeah, but they don't specify... I'll show you the table in a second and you'll see why I'm doing this exactly the way I am. They don't actually specify those alternative layouts. They don't specify. And now you know why USB in those countries is a pain in the ass for keyboards. Entertainingly, that one actually is specified. They have done UK versus US. Which you're gonna laugh when I do the constants for that. I don't know what Yugoslavia speaks. Well, according to the specs, there is. There. I mean, there is, Spanish. You can just say Spanish. Well, spec is old. I mean, it's from 2000. Thank you. Balkan. I'll go with Balkan. Because I think that was actually what they were aiming for there. This is the wonderful table. Ah. I hate it. So you can see, like, oh yeah, we'll define Arabic and Belgian and, but then, Japan. It's just Japan. And it's the Netherlands rather than saying Dutch. Because it's USB. I know it does. They're only specifying katakana. Enjoy. This is true. And there you go. Yugoslavia. Yeah, I know, but this is the whole stupid. So, you know, yay! Oh, they're going interestingly. Yeah, we've just confirmed the USB spec is Carpaccio. So we've just been dealing with this fun table of broken stupidness. They're making me want to cry. We never got PS2 to work right. I moved on to USB. Skipping songs. Capriccio. So my country code list here, I've tried to make it more generic than the spec by going with the names of the languages for the layouts rather than like countries. Because Yugoslavia doesn't exactly exist anymore, so we've decided it was probably intended they meant the Balkan keyboard layout. And instead of calling it UK and US, it's English and American. Yes, I'm really that person. Fair enough. It would be quite funny if I accidentally ended up with a lynch mob after me for writing keyboard firmware that said that. I would be like, oops! But it sounds like I'm safe, so... Yay! No, I did not get PS2 to work in the end. We gave up and I went to greener, sick pastures. And I'm currently dealing with the awfulness that is having to write descriptors because just I've got to test both. So, I mean, I have to bite this bullet sometime. And anyway, I'm getting to plunder an old USB stack I wrote, so it's fine. Oh jeez. Huh. Fair enough. I can't comment because I don't really know. I'm about to really want to hurt the USB head people, aren't I? Right, I'm actually going to start by moving this descriptor type and length into the... Huh, interesting. So we've got descriptor type and length, which is longer than normal. A lot of people use Zephyr nowadays for doing dialogues from scripts. I don't know how easy or hard it is to make it work, but Zephyr might well work well for you because it will always be installed on modern systems. Although at that point, it sounds like you really want to switch to a proper build system, in which case I recommend Meson. But you know me. I'm a Meson shill like that. I know though you want to be able to make this work with just the system tools. You don't want to have to force people to install extra stuff. You're a Meson shill too, Aki. I don't know what you're apologizing for here. Oh, I see. Yeah, fair. I have no idea how to fill one of these descriptors, so that's gonna be fun. Oh, you don't want to be doing that. I know how that ends. Mind you, I think you know how that ends too. Why is this written so badly? That's a good link. I do not care about physical descriptors right now. I care that I need I mean, WSL will have whatever the distro that the user's installed has, which probably means by default it's Whiptail. I start popping heads off and making them roll. But I think you already guessed that. Yeah, that works. It's fairly robust. Ah, you don't want to have to do that. But yeah. Oh, it is. But like, the kernel's not necessarily something to mimic here. Yeah. Well, it's actually even more than that. The kernel has an entire configuration system that can't be written in shell, so... Oh, okay. Have fun. Let's source that one. Yeah, nmiggen. Oh, if it's nmiggen, just assume System Python is available, and just do it all in Python. You'll thank yourself later. I mean, even the configuration dialog stuff, just write it all in Python. You can basically assume that if you run hashbang user bin env Python, that it will come back with a valid Python. Ah, okay. Erk. Rachel gets a better spec when? I'm ready to break something. I know that this is going to make it error. I'm okay with that because I don't know what the descriptor should actually look like, and I don't feel like fighting report descriptors right now. So, we've got 2 errors left to fix. GZIP's not installed on some enterprise operating systems anymore. Not by default, at least. So that's a little... Tar is, though. Kind of frustrating. Those ones both have, I know. Indeed. You could do worse than a .run file. That's all I'm saying. I.e., don't do run files, please. Go Galaki. The bzip 2 and stuff, yeah, no, none of those are installed by default on, like, CentOS. Oh, jeez, Aki. Oh, jeez. Well, if you're on an enterprise operating system and you're not dealing with compression-y things, why do you need them? You don't. So CentOS Core does not have them. You can install them, but they're not there by default. Makes things quite frustrating from a sysadmin perspective, though you are right to sheesh it. Right. Oh no, hide! No, I'm joking. Yeah, bash and curses is a whole thing. It's like it lives up to its name or something. I mean, technically it's rel that's the least common denominator. Well, I mean, lowest common denominator. Squiggly brace expressions, Aki. So what I'm currently looking at here... Yeah, I think you can do bitwise there. Huh. It depends, on how... Oh, God. Oh. Okay, yeah, because, to reply to Amy properly though, it depends, I guess, on how you're installing the package and what it is you're installing and whether it was actually designed to fit on that version of CentOS. We at work don't tend to have a problem with that, but then we also stick to vendor-supported packages for the most part. Fair. So we got some more Oscar knit stuff to do here. Yay! Because we need to do PLL control now. I'm guessing that's how that works. That's them just being dumb. If you've got Python installed and you're using the CentOS packages for stuff, then you have to use either a prefix install or a user install for whatever it is you want to override, or you will break things badly. And it's just really on you for doing it. Or rather on them, because I know it's not your... Oh, interesting. I didn't know Microsoft had hired him. Huh. Today I learned. It's like I'm reading the datasheet for a different chip to the one I'm using. What? I don't think that's that doomed. I'm just trying to figure out, like, you can go to a PLL clock, which I don't want to do because we've already got a reasonably fast clock on this thing. I think. Oh, I got that, Eston. I'm just having that moment of, wait, am I looking at the same datasheet for the chip that I'm actually using? Oh, I'm looking at the clock registers. Oh. Okay. Not anymore. USB has corrupted my brain. So we need 48 megahertz for full speed. Talk to you tomorrow. Thank you for coming and watching. So we want a 48 megahertz oscillator here. All I have to do to make it work with DOS and BIOS, well, DOS is covered from the fact I'm doing PS2. USB-wise, that is covered by setting this boot interface in the interface descriptors. You do that, make sure that the interface is the first interface in the list, and you're good. Even though I'm going to do a composite device, that's all you need to do. Yeah, so it's probably because they haven't got the keyboard interface as the first interface. It must be the first interface for it to work with BIOSes. UEFI is a lot more relaxed though, because they have proper drivers, but... Indeed. Oh, actually, probably should be quite a bit of fun. I would love to know what the PLL clock's up to so I can set the fucking divider. Like, I don't know. Yeah, that's fair, Aston. Enable the reference source. Set the multiplier. Wait until clock source is stable. Enable the PLL. So I'm betting this is all oscillator register stuff here. Okay. Yeah. But they're also really annoying different two-wire interfaces, or two-line interfaces. One of the things I'm thinking is I'm going to work a bit on Glasgow's PS2 support so that you can do better debug, etc. of this kind of setup, because obviously that didn't go so well today. The current applet is a little bit simplistic because of some perceived limitation. I don't know how realistic it actually is in the way that the comms are buffered and like how it matters. I can test it, because the keyboard I'm using right now is PS2 as well. But that, like, means I have to hook up a PS2 port adapter, and... Hey, I know what the next adapter is that we're going to do for Glasgow. PS2 port adapter. Clearly. It'll be the most overkill adapter in existence because it only needs 2 wires. But that means what we can have is we can make the adapter sit on like this end over here with the port facing out there or something, just like a little thing here. I know it means it hangs out over the thing, but like... The other option there is to have the adapter sit on like an end or some, or over this connector with the port over here. Okay, I'm up for the challenge. I don't have the hardware to test half of them, but like, I can test PS2 and I can put the connectors on there for everything else. Sure. Sounds like an entertaining project. That actually, that's a good question. That actually makes me think, have the connectors all lined up on this edge here, so that it adapts in here and then fits over here, so you've then got this connector still free for other things. Yeah, and that actually also works fine because the connectors are mirrors of each other anyway, or rotated rather. So, like, that'll be fine. It really should. Let's make it happen. Right, I'm getting distracted from trying to find the oscillators. Ooh. I don't know that anybody is working on GPIB, to be honest. That's a really good call. So we've got PLL clock source, which we've now got set. And then a multiplication factor. So I think that's probably ideal, is if we ask the PLL to multiply up to 48 megahertz, that is a multiply by 4? Let me just check that. Three. It's a multiply by 3. Now the question I've got here is, does PLL fac mean the factor minus 1? Or is it just the straight up factor? I don't know. I think because they're saying up to 31, this is just the raw number. Can we find any information documenting this? Oh. Shit, yeah, it's just the straight up factor. Excellent. Is there any way we can know if the source is stable? Awesome. You can send a friend request my way, I think, if, yeah, true. But if you've not already done so, you can throw one my way as well. I don't recall. Yeah. It doesn't look like there is a validation I can do that the PLL is up and stable. I just have to assume it, I think. Whatever. It'll be fine. What's a little bit of clock drift between friends, right? So USB control, set the PLL as the clock. And enable. We need to do the enable too. Oh, bollocks. That's what I was trying to do. So we can say we don't want to do any pre-div. We want the PLL on and we want to enable the clock source. Seems about right. Ah, I see. OSC or clock. This is oscillator control, isn't it? No, this is clock control. Wait, no, I was right the first time around. Bloody hell. So we want to do PLLN Then we can do a while ask status for that busy loop until it comes happy, and then switch the USB peripheral's ability to use it on. Cool. My brain feels like it's already become jelly. Wonderful. Oh, goodness. I don't want to know, do I? Oh, really? Okay. Well, that seems happy. Well, fair. So we enable USB in full speed mode with 4 endpoints at this moment because we don't have all of them enabled right now, or rather configured. Technically we're good for up to 6, but yeah. So endpoints 3 Yeah, because it's out, in, out, in. So now we know we've got the right clocking. Oh geez, when did it only get to 6 hours? I should try and wrap this up. I have, and this is starting to really burn my brain because, well, geez. So EP1 in needs to be a interrupt endpoint, which for their purposes is a bulk endpoint, but it's not because okay, so each endpoint has its own data buffer. This is awesome, because what we can now do is we can say, okay, we'll do, say, 64-byte endpoints because we've got the space for it. Ooh. Oh, talking of... I have a part for you, Esden. Let's just check it fits. Oh, made for it. That's the proper mating part. I'll get you the part number and I'll send it to you. I have a whole pile of them for reasons. I mean, yeah, but it works. Like, that comfortably fits. Oh, I see, you're looking for a new connector rather than these parts. Fun, fun. Aye, and that's a big pain in the ass problem for you. Sorry, when you said the connector, I thought you meant this part. That's fair. Yeah. Good luck. Yeah. Well, at least locally, I'm happy, given I have these. I've got a whole pile of these. I'm happy to make sync cables for people in the UK for a bit and send them out. I've got enough at the moment for 5 sync cables. So 4 really, that I can make. So if Atty, for example, needs one, then sure. But if Atty's going to be working on Glasgow, I might as well send him those a couple of those connectors, because they're kind of a pain in the ass to get your hands on. Like, I think the minimum order quantity was like 10. So we've got a size here, which I'm going to set as this. Take care. So we're going to do 64-byte blocks. So we have a stud array of uint 8T we'll call it EP buffer size. And this is okay, so what this allows us to now do is finally fix up this. This. I think our descriptors are now error-free. Well, at least compile error-free. Ooh. Nice. Yeah, that's fair. Thank you for reminding me, I need to buy a couple more USB Type-C cables, because now I have a legitimate need for a USB-C cable that's not my phone's one. Which also means, like, I'll need a cable for the keyboard because we're gonna do a Type-C version of this. And then there's that, and then, yeah. Ooh, I appreciate the paracord, that's awesome. Actually, do I want to do that way, or do I want to do a dumb for loop? Can I do this? I wonder. Ooh. I look forward to that stream. That works! Oh, no way! Oh, right, it was this header. I love it. Take care, Aston. So this is stud uint footer t that we need to go to. That's so cursed. I love it. Oh, okay, that actually compiles with a warning. It compiles with the warning that this is only allowed in C++ 20. Ah. Aww. It's okay though. Yep. Oh right, I can't make that there, I have to do it inside the lambda, but that's okay. That compiles and links just fine. God, this is so cursed that I can do that in firmware. And it's good code. That'll have generated nice code. I've just gone through and blasted every endpoint here with a buffer. So we've got all the buffers, and they're assigned to their proper endpoints. We'll deal with multi-packet transfers later, I think. Isochronous doesn't have the stall stuff, so that's a whole thing. But we're not dealing with isochronous. We only need to care that we do have a stall bit, and we can set it. So I'm going to stall endpoint 1 entirely. Because I can. It solves a headache. Let's put it that way. Oh, really? There is no fucking value for it. They didn't bother defining that. That's cute. Also, I might use that in the future. Isochron. I approve. So what I'm going to do then is const expr static constituent 8t USB EPCTRL stall is hex 4. No. 0, 1, well, 1, 2, 4. I don't love it, but I also don't hate it too much. There we go. That means I just have to figure out how I have to configure EP0 in and out. Which I'm going to pilfer from here. If I can find how I did this. I really need to know how I defined this. Okay, I have a table of the damn things. I get the hint, dear. Thank you. I'm just trying to figure out one last thing, which is basically how do I tell this that I want endpoint 0 to be a control endpoint? Because we have to configure it somehow. I think endpoint 0 in has to be a bulk endpoint. USB is horrible. I hate USB. Oh, that's so easy to understand what the hell they're talking about there. Not. Oh, we didn't do the string table. Damn it, we need to do the string table as well. Otherwise we're breaking the spec really badly. Like, my PC will be really pissed off at me. Interesting. I think if I recall correctly, one of the first packets that comes in is a address packet. It would be great if it would talk about how EP0 has to be configured. Sure. Fine. I'm going to assume that this is a bulk endpoint because it's going back to the PC and it's therefore a data endpoint. So if we think this is what I want. Yeah. Heh. Cool. Oh, that was the wrong one. So, we do get USB talking. I just unplugged the wrong USB device. And as you can see, it just kind of gets upset. But USB responds. Yay. So that's one thing down. The device not responding to the setup would be because I stalled the endpoint on purpose. This is a not terrible USB stack to have to deal with. So with that... Fair. We have managed to verify that. We didn't do any of the other bits, but that's okay. We'll see how things go, but I'm going to probably do some streaming of the firmware for this, because I need to do USB on this as well, which is going to be a riot, now that I've got the oscillators up and working. And that's probably going to be tomorrow, maybe, we'll see. I'll work with Aki on when we each do streams, or if we do a joint stream, or what have you. I may or may not stream, I don't know. Certainly next Saturday, though, I will be streaming, I think, another episode of this. Because, well, this has been interesting. I need something long and stiff now. USB is just awful. But hey, it's now more of a USB keyboard than it was. So there is that. So with that, I am going to call it about there. Thank you all for joining me, and have a fantastic rest of your day. And I will see you on my next stream, be it tomorrow for SPI Flash Programmer Firmware, or next Saturday for another episode of this. Thank you very much. It's... yeah, USB. USB is USB. Take care, everyone. Bye.